Hello, everyone. Thank you for joining us on today's webinar, Get to Know Sony's 5G IoT Portable Data Transmitter. My name is Trey Carter, and I will be your host for today. In today's presentation, we will go over some specs, features, and benefits of the PDT-FP1. We will share some use cases, and then we will open it up to you all for any questions that you may have. Before we kick off, I wanted to go over some housekeeping items. First off, this session will be recorded, so everyone attending will receive a copy of the recording in a few days. After the presentation, we will have a live Q&A session, so you can ask your questions to our product experts who are presenting here today. At any point during our webinar, please drop your questions into the questions panel found at the right of your screen. If we don't get to your question live, we will be sure to follow up with you directly and provide the answers accordingly. It is our mission to get you the information and content that you can use. Please let us know if you would like a deep dive into the PDT-FP1, including hands-on tutorials and how-tos by answering the poll question on your screen. That is all my housekeeping items. So let's jump into today's presentation. All right, so besides being your host for this webinar, I am also the National Accounts Manager for Sports in the eastern half of North America for Sony's Imaging and Pro Solutions division. Through this role, I am responsible for working with Sony's clients at the collegiate athletics, professional athletics, and regional and national sports broadcaster levels in all of our various product lines. Over the last 6 months, a product that has been gaining much interest through my customers has been the PDT-FP1, which you are going to learn more about here today. Whether it's being utilized for increased camera to cloud capabilities, media transfer workflows, or ultra-low latency live broadcast streaming, the PDT-FP1 is a valuable piece of your production toolbox. Over the next 45 minutes, you will learn more about the product and its functionality and some of the various use cases that we have to showcase. Here is a quick look of what we will cover today. We will give an overview of what the PDT-FP1 is, and our product experts will dive into the key features of this device. We will also share some use cases, and finally, we will be answering all of your questions live if you use that question panel on the right of your screen. I'd like to introduce you all to today's speakers. First up, we have Eldine Nadia. Eldine oversees a wide range of product categories, including cameras, accessories, mobile phones, 5G IoT devices, as well as software and cloud services. His responsibilities include product development, lifecycle, and management, and he has brought over 1,000 products to market over his 20 years at Sony. And we also have Martin Lindsay. Martin oversees broadcast cameras, production systems, and wireless workflow solutions for Sony. With over 22 years of experience in the broadcast industry, Martin is recognized as a subject matter expert and has been a featured speaker at numerous national and international industry events. His responsibilities include managing Sony's wireless video streaming products and technologies, ENG camcorders, as well as integrated production and workflow solutions. All right, so now that you know our product experts, let's get started. Eldine, I'll pass it to you.
Thank you, Trey. So let's start off by talking about what the PDT-FP1 is. And as Trey mentioned, PDT stands for Portable Data Transmitter. When you look at this image, you might think it looks like a phone. It's not. It is based on Android operating system, but it is not a phone. What it is, though, is multiple things. It's a external professional monitor. It's an encoder. It's a transmitter. It's a 5G Wi-Fi router or Wi-Fi hotspot. And as mentioned, it's based on an Android operating system. So if we pause here for a second, I can show you what the device is. And this is what it looks like. So you'll see that it's about the size of a large Android phone. It's a 6.1-inch LCD. You can see that it's a little bit thicker because it has an integrated fan. It's got heatsink. It's got multiple connections that we're going to go through in a little bit. at the back, so HDMI, LAN, USB, and it also has mounting points. So that's kind of a look at what the device actually looks like. What is the device made for? So this is really built for transmitting video, photos, and data from a camera or a device using a wired connection to the PDT. Now you can do a wireless connection, but obviously a wired connection is a lot faster. And then utilizing either Wi-Fi, but most importantly, the 5G mobile network to get that data or video or even live stream from the camera to the cloud. That's the primary use of the PDT. So let's have a look at a couple of those key features as we go through here. We're going to talk about three main segments. The high speed with wide coverage. I'll explain a little bit more what that means. Stable communication, and then also simple workflow. So as we start off with wide coverage, this is built with an incredibly advanced antenna system. It forms a 360-degree bubble around the device that can pick up from any direction. And it also has connectivity to the 5G network from sub-6 millimeter wave and C-band. And that essentially means that you can capture sub-6 as long distances. Millimeter wave is high throughput, but it's got a very short distance. You have to be very close to a tower. And what this antenna system does is it boosts that, so you can capture further away than normal devices, and it also has a higher throughput than what normal devices do. So basically, it's built to outperform a typical 5G device. Maybe you're utilizing a Wi-Fi hotspot or a transmitter already. This is really built to outperform that. So how do we monitor this? It has a built-in network visualizer app. This allows you to see exactly what direction your signal is coming from, how strong that signal is. This works for both your Wi-Fi and your mobile network connection. You see it's got both SIM card over there, and I'll talk a little bit more about that in a little bit. But you could also then optimize the position or location that you're standing to increase your signal. In addition to that, it has dual SIM. This allows us to have two different SIM manufacturers. So we can do SIM switching. You can have, let's say, for instance, T-Mobile or Verizon and AT&T. It has one eSIM and one physical SIM. And then you could set parameters on the device so that, let's say you have a minimum that you need a 5 meg upload speed, and as soon as it goes below that minimum, it'll switch to the second network that you have installed. So one eSIM, one physical SIM. We're approved on all the major MNOs, the mobile network operators, so AT&T, Verizon, and T-Mobile in the United States. And it's a global device, so this will work if you move to other countries or you have productions that are in other countries as well. So long periods of record time, this is based on two things. So a lot of devices will overheat very quickly, especially if people are using mobile devices. We found that even mobile hotspots overheat. With its integrated fan, its active cooling system, and its heat sink, we can record or live stream for very long periods of time. And in fact, at NAB earlier this year, we did a 4K live stream that was about 8 hours long, and the device didn't even get warm to the touch, even though we were indoors at NAB. So we've tested it in all different weathers. It obviously it has its limitations on the upper ends, but it's actually pretty robust in most situations. In addition to that, long battery life. So it has an integrated battery, a 5,000 milliamp battery. It lasts for a very long time, but we also have dual USB, and both of those could be used for power delivery. Now, the reason why we have dual USB is that the one could be used for power delivery while the other one is used for data transmission. So I showed you the physical device, but if we have a look at it on a diagram over here, you can see that it has multiple inputs and outputs. And I say inputs and outputs because they work in both directions. So you have RJ45 LAN cable. You could use that if you're taking internet off of a modem, or you could use that for data communication, for instance, from the device to a camera or vice versa. I already mentioned the two USB ports, and then it also has a full-size HDMI, which allows us to get video input from any device that has video out via HDMI. It has a quarter 20 mount on the back with Arri pins so it doesn't rotate, and it has a little loop that you can lock down your HDMI cable. That actually works extremely well. I've tested that quite a bit. As I mentioned, dual SIM cards. There's a eSIM and a physical SIM, as well as a micro SD card slot. Now, it also has 256 gigabytes internal SSD, And you can expand that with a micro SD by an extra 1 terabyte. So you can essentially have 1.25 terabytes storage on the device. So moving over to the workflow, we've devised a workflow to make it easier with Sony cameras, but it's not only limited to Sony cameras. There are also other applications that you can install. So if you're using a different type of camera and it has its own Android app, you could use it as well. What we did build into the menu system, though, is a wired connection settings. In other words, if I'm utilizing the LAN cable for a specific task, I can then tell the device that every time I plug a LAN cable in, it needs to launch a certain app and connect to an FTP, for instance. And I'll give you an example of that. This really makes workflow a lot easier for professional photographers and videographers out in the field, that they don't have to go through the setup process each time when they connect their camera to the PDT-FP1. So we've also incorporated a number of Sony applications that ships with the product to make workflow a lot easier. And this goes from photo-specific applications, our camera to cloud, both for consumer and for broadcast or professional users, enterprise users. And those incorporate access to go directly from camera to C Media Cloud or to our C3 portal. All right, so let's move on to a couple of case studies so you can see how the PDT-FP1 has been used by different industries in the production and photography market. First of all, professional photographers. So professional photographers, especially journalists and sports photographers, need to get the images from their camera to their photo editor as quickly as possible. So this is typically what happens, in photojournalism. At the Olympics, a number of photographers, quite a lot of photographers actually, were using the PDT-FP1 for transfer and tagging. And what they typically do is they'll have the PDT-FP1 connected to a belt loop. They'll have connected via a LAN or RJ45 cable, which locks into the camera and locks into the device. It doesn't come loose. And then they'll have the FTP set up with IPTC data. In other words, the photographer's name, the event they're at, maybe the specific event. Let's say somebody's shooting, women's gymnastics in the finals. They can have all that information. So as they're taking photos and they tag a photo and they can do voice to text, they can call out Simone Biles wins gold, women's finals, and that gets written into the IPTC data of the camera and gets uploaded to an FTP site. So now you can have a remote editor that's getting hundreds of images from hundreds of different photographers at an event. And they can open the image, have a look at it, and then see all the information. They give the photo credit. They know exactly what event it was. They even have voice to text in terms of what the relevance of that specific image is. So this becomes very convenient and useful. And what we're finding is that most of the media associations are picking up the PDT-FP1 to attach this to their cameras. So the next application is for individual live streaming, one camera live streaming for content creators, and then also for smaller businesses. And we see this in a number of different markets. This could be photographers that are doing live streaming services at weddings, small enterprise or businesses that are live streaming events, as well as some other unique examples that we've come up with. Now, I will show you a quick demonstration of how quick and easy this is to set up. And I had a camera set over here, and we're going to do a live stream very quickly. And I can show you also how we incorporate the external monitor function, which is our professional monitor. So if we have a look on the screen over here, this is my FX series connected to the PDT-FP1. And what you'll see on the screen is all the information on the left-hand side here. That's the input coming from the camera. All the information on the right-hand side here, these are connection, or these are settings in my external monitor app. Down in the bottom left here, I can switch between using it as a monitor or using it as a streaming device. And you'll see that on the camera itself, I've got camera detail that's over there. So I can go into my camera menu and I can turn that off really quickly so that I have a clean output out of the screen. And we'll turn that off. And that is going to give me a clean screen output. So you can see that is going to be what's broadcast. And on my camera, I can still see the full screen. Now, as a professional monitor, I've got different screens over here that I can have a look at, different displays, and I can set each one of those up. So for instance, this display I can set up for, let's say, exposure. So I've got waveform, false color. this one I've got set up. I've got a grid line. I've got peaking, so I can use this for framing and for focus. And then I can simply switch between those by hitting this button here, and this will toggle between those different displays. If I want to do a live stream, I go to the bottom here. I click on live stream. You'll see this live stream button appears. I have my settings menu right next to that. If I go into the settings, I can go into my streaming settings, and here I can select between RTMP or YouTube. So I'm going to select YouTube, and you'll see the RTMP setting menu. That's my stream key. Here's my password that I would set in. If I go and log into the YouTube, there's my YouTube account. I've already logged into that, and I can create a stream, and it's as simple as, now that I'm connected, going and hitting live stream. This is all the detail that I've already set up. I hit OK, and when that white box appears around it, we're actually going live. Okay, so you can see how easy it is to set up a live stream either to a social media channel or to RTMP. You can bring this into your own online switcher, OBS, many different use cases, everything from individual content creators doing live streaming, wedding videographers doing a live stream, even multi-camera. You can also do news reporting. For instance, news gathering, eliminating the need for a big OB truck and microwave signals. You can now have a small camera crew, or even the host setting up the camera, hitting the live stream and standing in front of the camera and streaming back to the news channel. So very, very easy device. Plus you have the benefit of having a professional external monitor that you can obviously frame and set up your camera and see on a larger 6.1-inch screen as well. So drones and industrial use, the similar way is we'd use it on an individual photographer in a journalist situation where they're actually taking a single image with IPTC data and sending that to a photo editor. Imagine a drone that is doing photogrammetry around an asset, something like a bridge, or in this case, you see a wind turbine. It could be a cell phone tower. It could be general infrastructure. If they're doing those photos, usually there's hundreds of images. So for instance, a cell phone tower, they're going to take 800 images. Typical workflow would be fly the mission, land, pull the card, upload those later on. Here in real time, you can be sending every single image with the IPTC data, who the pilot is, what the project is, what the tower number is, going to an FTP. By the time that pilot has landed the drone and packed it back into their truck, somebody's already created a 3D model. So this really speeds up workflow in a lot of different industries. One of the companies that we've just recently started working with is KSI. They have this issue where they also need a live stream video. And they have their own application that they've installed, their own Android app that they've installed into the device, and they can do a live stream of both the video from the drone as well as telemetry and data that they're pulling off of the drone as well. So this speeds up their process, and they don't have to create their own hardware. So they can have multiple inputs that they can bring through different PDT-FP1s. Each input would require their own one to go up to the cloud. Their previous system utilized a larger, almost a case that they had custom built in order to do this. But now we have a device that actually does it for them, and it goes into their own software as a service online that they can control each individual device and input and then share that out as well. Similarly, we're working with companies like GP Extreme. This is another use case where they're utilizing the video input. They're coming out of a custom box that goes into a race car. It can pull all the information from the race vehicle, the speed. It's got accelerometers. It can pull the G-force. You can even get the driver's heart rate as well as the position on the track through GPS, and 2 camera inputs as well as the camera that's on the PDT, and that can be streamed back to the pit lane in real time. That's used for driver instruction, so the latency is so low they can even tell a driver, brake for this corner before they crash off the track. So they use it for driver instruction. You don't have to have an instructor in the vehicle with them, and you can actually give them instruction in real time. But now, with this new technology, they can also stream that. So they can take that video stream and go live onto YouTube or into an online switcher. And a lot of the car manufacturers that have their own racing series are looking into this now as well, saying, wow, we can actually have one of these in every single vehicle and be able to stream their cup championships in real time from each vehicle, while also getting data to the pits from the vehicle itself. So I'm going to switch over and I'm going to introduce or hand over to Martin. He's going to be talking about the broadcast applications for PDT.
All right, thanks, Aldine. So I'm going to talk today about our experiences with broadcast and how we can integrate the PDT with our broadcast solutions. Really starting with a wide range of camcorders, not only camcorders, but really any camera from our Alpha series up into our ENG style news cameras, as well as our cinematic cameras as well. And even the possibility to connect the PDT to non-Sony devices as well, such as USB connections, Wi-Fi, and also USB tethering. So we do have an application that's called the Creators App for Enterprise. And this is allowing us to connect to the PDT with this app to a professional camera in a very simplified fashion. And to do this, it allows the operator to basically create a QR code on the camera where you can scan using the app on the PDT to register the camera to the PDT and the application itself. Once this is done, the camera can transfer clips into the PDT. And the beauty with this is as soon as you're done recording clips, every clip will then start pushing up into the device where it can then be cached and then transferred into the cloud. And the beauty with that again is that if you're in an area where you don't have Wi-Fi or 5G or even 4G connectivity, your camera could be pushing these clips into that PDT, into the storage device where it's being cached. And then when you're done your shoot, you pack up the camera, you walk out of the facility, and now you have connectivity. Your mobile device, the PDT in this case, will then transfer those clips into the cloud. And the cloud that we're talking about here today, that I have in the picture here on our slide, is Sony's C, which is really a cloud sharing platform that allows you to do a lot of powerful things. But in short summary, some of the nice features that it has is the ability to actually play out MXF clips, professional style codecs and things like that directly from the browser without having to have any issues that you might have with other providers out there. In addition, you can do other things as well with C, such as creating file requests so people can share files into your cloud system, as well as you're able to share your images or your videos with people as well. We could do a whole nother presentation on that. But again, really what we're just trying to get to explain here is the fact that simplified connectivity with the PDT to the camera and getting those files and that media into the cloud. In addition to that, using this application, the Creators App for Enterprise, we allow you to give you the ability to actually do metadata entry as well. So if you're doing recording clips out in the field and the photographer wants to add metadata, they can do so. They can put things in pretty much any kind of metadata they want. They can they can customize it any way they need to. So they can do location, they can add the photographer, add the talent name as well. And then you'll see on the right-hand side there the clips that are available to upload into the C Cloud, the Sony C Cloud. It will show you the status of the transfer, and then we'll also allow all the files again, whether it be proxy clips, whether it be images or MXF clips, for example, all to be delivered into the cloud environment. So Aldine talked about being able to do video transfers live streaming through the PDT because it does have that HDMI connection. In addition to that, what we're offering here is we have another product. It's a low latency encoder, or actually an ultra low latency encoder. It's called the CBK-RPU7. And this is used in the professional broadcasting world for getting really low latency video. We're talking 33 milliseconds, 2 frames of latency from encode to decode, plus a little latency of the network, but really ultra low latency, which is important for sports productions as an example, where they can do live switching using these feeds. And this is just an encoder. So I say just encoder, it works in tandem with the PDT. So the PDT is actually the transmission device that connects to the 5G networks or Wi-Fi networks or whatever network you have available to you. And then that is connected to the RPU7 here, which does the actual encoding for you. The encoding with this is anywhere from HD, you can do 12 megabits, starting at 12 megabits per second. And if you're doing 4K, you can do start a stream at 35 megabits per second. Now, those don't sound generally high, but again, that's an ultra low latency, very, very high quality, again, used for professional productions. So I just want to go over some experiences or some great opportunities that we've had to work with some broadcasters doing some major golf tournaments or covering some major golf tournaments recently this spring. One of them was at Valhalla, and we worked with CBS in this case. And one of the challenges that you'll have at an event like this for production in general is the sheer amount of people. So when the sheer amount of this amount of people show up to an event, the cellular networks get quickly oversaturated. Now, the cellular companies will go out and provide what they call CAL, cellular on wheels, to help alleviate, provide more coverage and help alleviate any degradation for the users. But what we're looking for in the broadcast side is high upload bandwidth, which is definitely challenging to get in such environments. So this is where we actually work with the carriers to provide a private 5G network, and I'll talk about how we did that in a little bit here. I also want to talk about some of the challenges that production companies have generally with the traditional ways of providing or deploying cameras throughout such large terrain or such large areas, such as a golf course. And actually, these teams here that you can see in the images here, they will go out 2 months in advance to a golf course and start laying this infrastructure. So there's tens of thousands of feet of fiber. You're talking well over 100 cameras to cover all 18 holes, which they and a lot of that cabling has to be dug into the golf course. So there's obviously the cost of all that infrastructure. There's the cost of the labor, the travel and expenses to do that. And we were working with CBS in this case to help alleviate some of this by providing 5G connectivity using the PDT and the RPU7, the low latency encoders. And the way we did that is we did it with private 5G. Now, you hear about 5G in general, but what we did at the golf course here is we actually deployed a private 5G core, which you can see on the left side. There's a small rack of equipment. And that is really your own private 5G network, kind of like having your own Wi-Fi network. This is your own private 5G network. And that's the core of it, which was then connected to multiple radio antennas that were located throughout the golf course to provide that 5G connectivity. Now, these were placed generally in the vicinity of key signature holes, such as hole 13, also hole 18 that was covered as well. And the beauty with this is when 50,000 people would show up to Valhalla per day, it's 200,000 people over 4 days. We didn't have to worry about the private 5G network being affected at all by any of the public users. So with the 5G network, the private 5G network, we actually had consistent, steady upload speeds of about 500 megabits per second. I also want to just talk. So that was a very special case, and the mobile network operators such as T-Mobile, Verizon, AT&T are working on being able to deploy private 5G as like a kit where you can actually rent it, deploy it for an event, and then give it back to the carrier. One other thing I want to also talk about is public 5G slicing. So this isn't publicly available yet, but what the carriers are looking to do is be able to slice a portion of the public network. And by slicing it, what they can do is really give you an allocation of a specified speed and guaranteeing that speed as well as latency, providing lower latency. So that is something that is in works with the carriers. They're working on the business models for that now. But we did also test that on Valhalla. And the way we tested that is we had a number of photographers who were taking pictures throughout the day, 500 pictures on average per day they were taking. Their alpha cameras were connected to the PDT, and all the images were being transferred from their alpha cameras into the PDT, which then were going into the cloud destination of their choice. And all that happened really, really quickly. And what that did is it saved the photographers the time from having to stop what they were doing, take the media out of the camera, go to the media tent, put that media in a laptop, get connectivity to the internet, and transfer those clips. So that made them, basically allowed them to prevented them from having to do any of that, and allowed them to do more of what they do best, which is continue just shooting great footage. So this is just one of the typical camera configurations, or a couple of camera configurations that we had at Valhalla. On the very left-hand side there, we did have some studio cameras that were connected with an encoder and the transmitter. Again, that's our new RPU7 encoder, as well as the 5G transmitter at the top, which is the PDT-FP1. So that was the build-up kit. And again, that was connected to the private 5G network. And then also in the middle, we had a Sony cinematic style camera. They wanted the shallow depth of field look. And that was an FX6 camera that was also connected to one of the CBK RPU7 encoders and the PDT-FP1 as well. So that was on signature hole number 13, where they were using that, I think, for about 10 hours, 10, 12, almost 12 hours a day in 95-degree heat in the sun as well. And the PDT was just running all day long without any issues of overheating. So that was one of the key things with that as well. And what he was doing, the photographer here, was shooting the players as they were teeing off and then following them down the fairway all the way to the green. So on this one, this is really how the streams got from the cameras back to the production switcher. So we have the venue, obviously, which is Valhalla Golf Course, and we also had the truck. So the trucks in this case were located at the golf course, and they were accepting all the streams from the cameras in a decoder in the truck, and then they were doing all the switching in the production switcher within that truck. Now that truck could be anywhere across the country as well. It didn't necessarily have to be local. And the idea with that is in the future, if you can get this back to a central production system, you wouldn't need as many trucks out in the field. In this case, I'm showing 2 cameras. We had a total of 4 cameras at the Valhalla event, and we were comparing those with the fiber connections as well as some of the microwave connections. And the low latency and the video quality were definitely superb. And then I think this is my last slide. This is just a real quick kind of overview of the connectivity as a photographer. Also the private 5G network in the middle there, and then the shader, which is the operator at the truck. So a couple things here. We're doing 2 things really. One is we're getting the live stream back from the camera. So that's a live stream through the encoder, through the PDT-FP1 into the 5G network, and then out to the decoder on the bottom right-hand side there, which was then feeding the truck. But what's also really important with live video, especially for live sports production, is the need to control the camera remotely. And that's what we call the shader, who would be in the truck, who would be able to do iris control and adjust the look of the camera, so all the cameras can look like they're in sync in terms of the actual look of the output, in terms of having the same iris and color temperature and things like that as well. And we were able to do that with an RCP through the 5G network through the PDT. So I really want to highlight the connections of the PDT here. So the PDT was doing the connection to the encoder. So it was getting the camera feed, which was SDI to the encoder, which was then connected through a USB tether into the PDT-FP1. That was handling the live video stream. And then because the PDT-FP1 has an RJ45 LAN connection on the back of it, we were able to use that to connect directly to the FX6, which would then provided us the gateway or the connectivity to have that RCP control of the FX6. So this was a really, really big bonus to be able to do this again, all remotely from the truck, shading the camera, and of course having the live video control come back through a single PDT device. So that was just a really good example. And I think that's about it. So we're going to pass it back to Trey for any Q&A. Thank you.
All right. Well, thank you, Martin. Everyone, thank you for your time during this session. So we are now going to be taking questions from the audience. If you haven't already submitted your questions, please do so using the questions feature found at the right side of your screen. Also, if you would like to see more in-depth products, how-tos, so how to use the PDT-FP1, go ahead and fill out that poll that is also currently posted on your screen as well. All right, so diving into some of these questions. Martin, I know you just tossed it over to me, but there are some regarding 5G. So since we're on that topic already, I'm going to throw a couple back at you. So Jason asked, can you actually purchase a 5G system without any carrier involvement?
Yeah, so technically you can buy the equipment, but typically for the uploading capacity or the high bit rates that you need for uploading, you'd be looking at using spectrums that would be required from the carrier. So typically you're going to be using a carrier such as T-Mobile, Verizon, or AT&T, using one of their systems. And as T-Mobile just announced, they're releasing basically a portable 5G system that will be available for lease or rent or something like that. starting at the end of 2024. So that's the best way really to go, because they will provide all of the spectrum that's really required for a private 5G network.
Perfect. And then I know Jack put one in the chat here as well. How long does it take to set up a typical like 5G private network in order to get it set up, deployed, and active to use on the PDT-FP1?
So they're getting easier. They are definitely getting easier to set up. Like that's a small rack kit that goes out as the core system, and then it's really just a matter of setting up the radios, the radio antennas in specific locations throughout the venue, and that's typically done in part with the carrier. The carrier will help design or figure out where you need to put those or deploy those where those radios should go. So that's typically done fairly quickly. I mean, for a small venue, you can do that in a matter of, pretty much have the system set up in a day. You might spend a day or so before that working with the vendor to figure out, or the carrier to figure out where those radios are going to go, and figure out the logistics of the system. But it is getting easier. As we've done more proof of concepts with customers, the carriers have been making the deployment of such systems much easier. So we should see that more common in the coming months and coming years.
Perfect. And then one more here for 5G, so we can get Eldine kind of hopped into some of these questions as well, because we have a lot of them right now. But Kurt had put in to the chat earlier, right after this presentation had started, asking if the PDT-FP1 is only able to be utilized over private 5G, or if you could use it on public 5G as well.
Yeah, no. So straight out of the box, this will work on pretty much any 5G system that's available to it. If you're going to be working with private 5G, you would obviously be working with a specially provisioned SIM card that we provide from the carrier for that access to the private 5G networks. But otherwise, yeah, it'll work with public 5G, works with 4G, LTE, Wi-Fi as well. Pretty much any common cellular connectivity out there, and that includes millimeter wave and sub-6 in the 5G spectrum.
Perfect. Thanks, Martin. So I know in the presentation we talked about kind of all the different ways that the PDT-FP1 can be utilized. One of them that we talked about was live streaming. A question that came out here from Jithan was that is it possible to live stream through the PDT-FP1 directly into Zoom?
Yeah, so you can basically use the Zoom application to live stream. It can recognize either the camera that's on the PDT. Now, keep in mind, it only has a front-facing camera, but it'll also recognize the HDMI or external camera plugged into it. Some cameras with UVC can be connected via USB as well. So UVC, UAC is USB video class and USB audio class. So it depends on the camera if you're going to use USB.
Perfect. And I know, the PDT, it looks a lot like a phone. It kind of feels like a phone.
Yeah.
We do
It's
just
more
kind of
like
want to
one.
make sure that everybody understands it's not a phone, right? It doesn't make phone
Right.
calls. If you're going onto a 5G network, we do recommend it to be a data plan rather than a phone carrier plan as well. So it acts more like a mobile hotspot. So talking about that, Jithan actually put in a second question here. So does it actually function as a mobile hotspot, even, because it isn't a
Yeah,
phone?
absolutely. So obviously, Wi-Fi capabilities connecting to a Wi-Fi network. You also have LAN capabilities, but you can also then utilize the device to create a Wi-Fi hotspot. So there's multiple ways of connecting to the device. So obviously, your SIM card, one E, one physical. It can do some switching. And then I think the current limit is being able to connect up to 10 devices to it. So if you create a Wi-Fi hotspot, I can have 10 devices connected and using this as a wireless hotspot. So, again, you could also use it in terms of a router with a LAN cable as well.
Perfect. So that LAN cable actually, it came up in one of the questions here from Peter. So he's got a couple different Sony cameras that he uses right now. Some A1s, some A7R4s, A7 IV.
Yep.
Has a couple other options there too. Some of them have LAN cables on the physical camera itself. Some of them don't. He's trying to figure out, can he use something other than the LAN cable. Let's say the
Yes.
USB connection to the PDT to transfer files off of those cameras direct to an FTP.
Correct. So I think that the question is coming up. Typically, what you find, especially in sports and journalist cameras like this Alpha 1, Alpha 9, they have a LAN cable connection there. This is beneficial for a couple of reasons. One is if you're in a stadium and you're transferring files, whether it's video clips or photos, typically in the past, you would have a run of RJ45 cable that would go from the field all the way back to the media room where you'd have photo editors sitting there receiving the signal. And photographers would either be plugged into the LAN cable while they're shooting, or they'll take their shots and right after an event, let's say they're shooting the 100-meter dash and they get all the images, they'll plug in the cable and transfer the files that they want to back. So you'll find that a lot of those type of cameras, the Alpha 1s, the Alpha 9s, will have LAN cable. Also beneficial when you're connecting it to the PDT, that if I have the PDT here, I've got a V mount and I've got this connected to my belt and I'm busy shooting, the LAN cable doesn't pull out easily because it locks into place. As you know, you've got that little pin that locks it in. So for cameras that don't have it, you can absolutely use the USB. So for instance, the Alpha 7 4s and some of the other cameras that you mentioned, you can go directly USB. And with some of the apps that we provide, like the transfer and tagging app, that can specifically be used to set it up as either a LAN or a USB connection. In addition to that, because this is an Android operating system, and we in the menu of the settings, we have a wired connection. I mentioned this in the presentation we just gave. Within the wired settings, you can actually go in there and set it that if I plug in a LAN cable, then do this. So you can set up a set of macros. If I plug in a USB cable, then do this. So for instance, if I'm out and I'm utilizing the LAN or the USB to transfer files for a photo shoot, I can then tell if I plug in a LAN cable or if I plug in a USB cable, specifically with a USB cable, if you think about the use case, open up the app and connect to the FTP that I've preset in there. In case that cable gets pulled out and I have to plug it back in, I don't have to go through that settings process again. It automatically recognizes what I'm doing. So long answer, but yes, you can use both USB and LAN.
Perfect. Thanks, Aldine. One of the things you mentioned there is different stadiums. So I'm looking through all these questions, and thank you everybody for putting them in. There are a ton of questions. So like we said in the intro, if we can't get through all of them here in the Q&A, we are going to be responding to you directly via email with an answer to your question. And then obviously, if there are some that we feel are more uh, pertinent to everyone that was here, we'll make sure that those get included in some of our frequently asked question documentations as well with this product line. But one of the conversations that's come up, as you mentioned, stadiums. Like I said, I'm specified on the sports side of the business, so maybe I'm a little bit more partial to those questions a little bit. But a lot of questions came up about use of the PDT in stadiums, use of 5G in stadiums, use of kind of this data transmission, whether that be with the NFL or whether that be with the NHL and the hockey side or even NBA stadiums. Is there kind of a recommended best practice for how to set up this PDT or utilize the PDT with your cameras in a stadium environment? Does that PDT need to be pointed directly at that 5G antenna? Is it better to orient it in a certain way? What are kind of the recommendations in that large enclosed space that has a lot of people in it at the same time?
I think I think we're gonna tag team on this. I'll start off and I'm going to throw it over to Martin afterwards. So I think first of all we need to recognize some of the limitations of the device. One of it is it doesn't have cellular bonding. So you'll find that there are other types of devices that are very specialized that will have cellular bonding that can utilize multiple cell phone signals together. We have SIM switching, so it'll switch from one service provider to the other one. The other thing is also to recognize how the device's antenna is set up. So it has antennas on all four corners. I do have a nice, when I only thought about it after we started this, I do have a nice graphic that shows how it forms kind of like a bubble around it. The network visualizer app tells you where your strongest signal is coming through. So human bodies are, thick masses of flesh. If you've got this down on your hip or something like that, and your strongest signal is coming from the opposite side, you may want to reorient this. If you had a look in the slides that Martin was showing, some of the photographers that were capturing the live stream from the golfing events, they had it attached above them on a pole so that they have this 360 antenna around them. So that's typically how, the use case for the network visualizer, to see where your signal is coming from, to see if you're blocking your signal or something else is blocking your signal. The benefit of having a 360 is if you do have it higher up, or you do position it, if you have a camera and you have a position on top of the camera, which I often do, you are able to get a full signal. Downside, though, is when you're in a stadium and you're not on a private 5G network, the minute that stadium fills up, it's going to be packed full of people, all have cell phones. Your signals are going to be diminished. So if you're on a public network, it makes it extremely difficult. But that's difficult for every service provider, regardless of whether you're doing bonding or non-bonding, to be able to fight through that noise, which is why private networks and private networks and public slicing is kind of the way of the future in terms of the use case for this particular model. So, an application. So I'm going to throw the rest of it over to Martin for best practices.
Yeah, so it really depends. I mean, Eldine did a good explanation on the device itself, but there's obviously limitations to the network typically that you'll experience in such a packed environment. And it doesn't matter really if you have 5 or 6 SIM cards on a bonding device. If you're only getting kilobits per second on each one of those SIM cards, you're not going to have a good experience. So those are actually the biggest challenges with stadiums, and they are improving. They're adding 5G radios and they're expanding the network, so that will improve in the future. So which is why we've been working with with some broadcast accounts to deploy private 5G networks where they would have an untouched access to a high bandwidth upload. That being said, the carriers are working on technology such as public slicing, 5G public slicing, where hopefully in the short term or the near future, you will be able to purchase a slice of a network at a stadium environment, for example, where you can utilize that for a guaranteed connection and guaranteed latency as well. So there's still a lot of things in the works, but yeah, as of now, obviously the biggest limitation is just what the network's going to be able to provide at any given time when you have 50, 60,000 people within that event. And that can definitely be challenging.
Thanks, guys. So definitely using it over 5G is, obviously something that everybody's intrigued about. Just to be clear with everyone, right? The PDT-FP1 is capable of doing 5G millimeter and sub-6. It can do 4G LTE. It could do Wi-Fi, and it can do LAN connection as well. So you do have that capability with this product line. To the point of 5G kind of congestion, Philippe here put a question in more regarding Wi-Fi congestion, but also I guess this kind of works towards 5G as well. In a perfect world, right, where congestion isn't an issue, where it is, we're not talking about thousands of people all being on the same network. How would we think that the PDT's bandwidth usage and overall kind of functionality compares between like 5G millimeter wave and 5G sub 6, but also between Wi-Fi 6 and Wi-Fi 5, and then Wi-Fi against 5G as well?
So I can tackle a little bit of that. So I think first of all, it's you need to understand how the 5G bandwidths work, right? So there's essentially what they usually determine as 3 different main bandwidths. Ultimately, it's in a spectrum of the 5G band, starting at sub 6. In between, we didn't actually mention it, but it covers this as well as C band and then millimeter wave. So sub 6 is going to give you the longest reach, the furthest distance. That's 99% of what we all use. So if you see 5G on your phone, it's typically because there's a tower somewhere that could be close, it could be far away, but that signal travels very far. The throughput on that signal, the megabits per second that you can up and down load, is a lot lower than on the opposite end of the spectrum. So the opposite end of the spectrum is millimeter wave. So the up and down sides of millimeter wave is that you have very fast throughput. You've got very fast data transfer within millimeter wave. However, it's a very short distance. You have to be very, very close to the tower or the transmitter receiver that you install. So what is typically happening is that there are 5G millimeter wave towers, but they're usually in very congested locations. You might find them in New York City. You may find them around stadiums where there's going to be a large quantity of people, and they need a higher throughput in terms of the signal that you can throughput. Whereas C-band is kind of that middle ground. It's the best of both worlds. So it covers the entire spectrum, and it'll choose what, obviously it attaches to whatever is available. If I'm far away from a millimeter wave tower, I'm going to be using C-band or sub-6. If I'm right on top of millimeter wave and I'm close by in a stadium, for instance, it's going to switch to using millimeter wave. So the device is going to use the strongest signal that it has for the application. So that's one thing to note. As far as the difference between Wi-Fi and cellular, I mean, it's really dependent, right? You have some Wi-Fi mesh networks that have a lot faster speeds than others. It depends on what's on the back end. So, for instance, where I'm located in San Diego, I'm on a satellite because we don't have any cable coming to our house. We're kind of a little bit out in the sticks. So I have very slow internet, which is also why you're seeing my camera feed is probably not the greatest. So my Wi-Fi is going to be slower than, say, for instance, somebody who's in a built-up area who's got, gigabits of transfer speed. So it very much depends on the network, whether it's either Wi-Fi or your cell phone network. I don't even have 5G where I'm at. I'm using 4G LTE when I'm testing with the PDT. I hope that answers the question. I don't know if that was
Yeah, I
exactly
think
what
so.
I was.
That's pretty good. And the 5G the 5G millimeter wave, as you mentioned, is shorter distance but much higher bandwidth, and also lower latency as well than a sub-6
Yep.
network. And obviously comparing Wi-Fi to 5G is really dependent on what the carrier is going to provide at that time. But to give you an idea, we were testing with private 5G millimeter wave at about 500 megabits per second at upload speeds, and it can go a lot higher than that depending on the configurations.
Perfect. Thanks, guys. So we got about 5 or 6 minutes left here before we got to call it with this webinar. So I wanted to just get two specific questions out there for you guys. Um, Obviously, we've been talking a lot about how it connects to Sony products, how it can work with the Alpha series cameras, the Cinema series cameras as well that we offer. The PDT, though, being a Sony product, obviously it's going to work with Sony products, but is it intended to work with other non-Sony products as well?
Yeah, so great question, and absolutely. So it is an Android device, and as we've mentioned, it's not a phone. It doesn't have any phone capabilities. I guess you could install something like WhatsApp and utilize that, but that's not really its main intention, right? So as a 5G IoT Android-based device, you can install your own applications on it. So if you have even a different camera brand that has their own app, you can install that app and utilize that with the camera. We also find that a lot of the media agencies, some of them will use our transfer and tagging app. Some of them don't. So these are, agencies like Reuters or Gartner or AP. And, like I said, some of them will connect to the FTP using our app. Some of them would use their own applications. And if they're using their own applications, some of those news agencies have, legacy cameras as well. Most of them have switched over. I think almost like 90% of them have switched over to Sony already. So they could use either their own app or our transfer and tagging, but they could obviously be using legacy cameras that are non-Sony branded as well. The HDMI allows you to plug anything with an HDMI feed in. In fact, if I want to come out of my computer with an HDMI feed and send it through the PDT, I can do that. So HDMI makes it widely compatible. Android makes it widely compatible. Another question I get a lot is there an SDK or an API for the PDT? No, not from Sony, but yes, from Google, because it's an Android device. We also have an SDK on our cameras. So if you need to create your own Android application, but also tap into Sony's SDK for camera control, we do have an SDK for that as well. So yeah, we optimize it for Sony products with the built-in apps that we ship with the product. Things like C Media Cloud, C3P, Creators Cloud for enterprise. Those products are in there. We have Creators Cloud for individuals, which allows you to go directly from camera to cloud, transfer and tagging app. That makes it easy for Sony products, but it's absolutely an open source product that'll work with other devices and other camera brands as well.
Perfect. So just to kind of put that concisely for everybody, it is available for all camera brands. You can utilize it with any type of camera brand as long as you can come out of that camera into the PDT utilizing any of the ports available on the PDT. And then from a destinations and endpoint of your media where it's delivering things to, it can be delivered to pretty much any location as long as that's working within your cloud enterprise. Like, it's not going to deliver to on-prem hardware, right? It's got to be something that it's going up into the cloud. But other than that, FTP, private, public, it doesn't matter all that much as long as you can create that end location from like an app sitting on that device itself. All
Trey's
right.
a great letter.
I'm learning here as we go as well. So, I want to make sure that I'm remembering it all correctly and that, we're getting
Yeah.
everybody the answers that they're asking. There's a lot of questions there, LD, and I will say a lot of questions in here as I'm scrolling through all of them. Is it FTP only? Is it FTP only? Can it go to a private destination? Does it have to be only Sony products being used on
Yeah.
this? So we do want to
Can we
make
address it? Yeah, can we address that other one quickly? So it's not
Please.
FTP only, right? For instance, you can stream video protocols as well. So, for instance, RTMP is already baked into our external monitor application, as you saw in the demo I did earlier. SRT is available through XD Cam Pocket as well as other third-party applications. So it's not necessarily just going to a FTP source. You could be going from the device straight to the web. We've done a lot of testing to our online web switcher, the M2 Live switcher, as well as other non-Sony online switches. OBS, for instance, you can go directly to social media sites. So there's multiple different applications for both file transfer as well as live streaming. And for instance, we mentioned the GPX Stream earlier. They have their own application that they installed, and they go through their own web-based application where they can control the stream. They literally have hundreds of customers. One of the at a single racetrack, they have 40 customers who utilize their service, and they can then manage those streams through their application for their live streaming or coaching capabilities. So it's more than just an FTP file transfer device.
Perfect, Aldine. You know what? I don't think there's a better way that we can wrap up this webinar than just making sure that people understand that this is a highly functional, highly capable device. It's not just FTP based. It's not just Sony based. It is a solution that is meant to solve problems for all companies and all product lines across, even some of our competitors. So definitely glad that we got to that one. Unfortunately, that is all the time we have for today. We do have a record of all the questions that you guys sent, so please don't think just because we didn't ask your question it won't get answered. We are going to provide these questions directly to Martin and Eldine. Make sure that we get these two specialists to really respond to your questions, get you the answers that you all need, so that you can really evaluate the PDT and its possible functionality with you all. So just wanted to thank Martin, Eldine, our production crew for all the time that they took to put this all together. That is, again, like I said, all the time we have today. We will get back to you with answers to your questions. And if you do have any other questions, please feel free to reach out to us utilizing any of the Sony inquiry forms to get in touch with us with those questions regarding the PDT, or potentially even schedule a demo with this product as well. So thank you all for joining us. We appreciate your time, and have a wonderful rest of your Wednesday.